Good afternoon, everyone. As discussed in the previous class, we'll complete some school related topics for some time, and then again we will start with straight lines. Okay, just a minute. Yes, so let's start. So the next topic is three-dimensional coordinate geometry. See, we have already studied two-dimensional coordinate geometry. What is there? There we have two perpendicular lines called x-axis and y-axis, and they are perpendicular and they meet at a point which is termed as origin, right? And with respect to origin, we start giving the coordinates. Okay, you know this is first quadrant. This is second quadrant. Then this is third one. This is fourth, right? Then there is some sign convention or sign scheme where x and y coordinates have these kind of signs, which I'm writing here. In the first quadrant, x and y coordinates are positive, right? In the second quadrant, x negative, y positive, and so on. Now, what happens in three-dimensional coordinate geometry? As the name says, three dimensions. Two dimension, that means x and y. Three dimension means x, y, and z. Okay, x, y, and z. So, how we will understand this three-dimensional geometry? First, let me make a diagram. So try to understand this diagram. Okay. Imagine this as the corner of your room. Okay. Like there is this wall OABC. Okay, you can visualize sitting in your room. This is OABC. Then this is another wall. Say OD, and let us take any other point E, and OA. Suppose this is M. OAMD. This is the floor, right? Floor and the two walls, adjacent walls, which I have named. Okay. And their meeting point, this point O, is called the origin. Now this line OA is along x-axis. Okay. OC is along y-axis, and this OD is along z-axis. Okay. Just like we have x and y axis, we have now three axes, x, y, and z. 3 dimensions. See, in geometry, you have studied diagrams or figures like triangle, quadrilateral, circle, etc. They are two-dimensional figures. They have 2 dimensions. When we say straight line, simple straight line, it is a one-dimensional figure. It has only length. When we say rectangle, it is a two-dimensional figure. So length and breadth. Okay. So that means we can represent two-dimensional figure like this. Suppose I draw here this rectangle. Okay. So I can say that length is like parallel to x-axis and breadth is parallel to y-axis. They are two-dimensional figures. Okay. Then comes three-dimensional figures like cuboid, cube, etc. In fact, I have drawn a cuboid. Okay. I have drawn a cuboid. So it is a three-dimensional figure. Okay, one of the dimension, maybe length is along x-axis, breadth is along y-axis, and this height is along z-axis. Okay, so I hope you understand this. So this is called three-dimensional figure. Okay, now what we need? We need to use these in coordinate geometry. So we'll have to give some coordinates. Then there will be something like quadrants. They are not exactly quadrants. They are octants actually. Okay, octants. And then coordinates will be there. So what I'm going to do, I'm going to draw one more diagram. Okay. See, this is X. Now try to visualize one thing. Okay. Try to visualize this X and Y axis is on the screen, right? Or on the page, whatever. Now I have to draw three-dimensional axis, three-dimensional Cartesian plane. But you should try to understand one thing, that our screen or a whiteboard or a blackboard, whatever, or the page of your copy, that is a two-dimensional diagram. And we try to represent a three-dimensional figure. Okay. So you should visualize the thing. I'm going to draw a third line. Okay, I am going to draw a third line which is perpendicular to both of these at origin. Okay, which is perpendicular to both of these at origin. We can draw it like this. Now see, what is the problem with this? The problem with this is that it looks like I have drawn a line in XY plane only. It is not like that. If you have to visualize this thing, then you put your pen or pencil, whatever, at origin and perpendicular to the screen, then you will visualize it. Okay, so this red line is actually perpendicular to both these black lines. Got it? So it will be perpendicular to the screen. You might have studied vectors. They say out of the screen, into the screen, or out of the board, like that. Okay, that kind of situation. And as you know, one direction is positive, other is negative. Like this is positive x-axis. Okay, this is your positive x-axis, and to the left is negative x-axis. Similarly, this is positive y-axis, and the lower side is below the origin is negative y-axis. Same is here. Same is here. We take this as positive z-axis, and the other side, which should be actually into the screen. Okay, and that will be negative z-axis. So what happens? These three lines, okay, these three lines divide the whole space in 8 equal parts. Divide the whole space in 8 equal parts. Now I'm going to tell you a very easy method to remember those octants and the sign conventions. What we are going to do, listen carefully. I'm going to use these capital alphabets, okay? Capital alphabets for positive directions and these positive alphabets with dash sign for negative directions. Okay, so when I simply write X, Y, and Z, I am representing positive directions of these x's, and when I write x dash, y dash and z dash, okay, we are representing the negative directions of these x's. Yeah, and this is origin. Now try to understand the three perpendicular lines divide. If you want to write the name, three perpendicular lines which are x o x dash, y o y dash and z o z dash divide the whole space. Do not use the word plane. Plane is for 2 dimension. Space, we are talking about space. Okay, divide the whole space in 8 parts called octants. In 2D you used to have quadrants. Quad means for 4, right? Oct means for 8. It is like that in 8 parts called octants. So there will be 8 parts, right? Now how to remember the octant number and how to give the sign scheme? It is very easy. I am going to write here the octant number. I am going to write here the octant number, octant name, and obviously sign convention. Sign convention. Sign convention regarding what? Or sign scheme of the points that you are going to write here. Now, before I write this octant number, octant name, everything, let us come back to this thing. Okay. Let us come back to this diagram. Okay. Suppose that I have to locate this point P. I want to write its coordinates. Okay. I have to write its coordinates. Let us do one simple thing, and you know that everything starts from origin, and now it is 3 dimension. So origin will have 3 coordinates now. One is for x, other is for y, and third one is for z. See, if you have studied this coordinate geometry in class 10th, then you know that distance formula, section formula, coordinates of point, everything, it is going to be same. Just the third coordinate will be introduced. Okay. So it will be very easy for you to understand. Just few different points are there. So try to understand. We start with the origin. In 2D it is 0, 0. In 3D it is 0, 0, 0. Now, suppose that we move, or I say, let us say the coordinates of A are x, 0, 0. Now, why the coordinates of A are x, 0, 0? Because the point A is on x axis. So the y coordinate will be 0 and z coordinate will be 0. Now in class 10th, when you used to write up, or you used to assume a point on x axis, the point you used to take was x, 0. Why? Because the y coordinate is 0. But now, since we are talking about 3 dimensions, so z will also be 0. Okay. So taking this as x, I was able to write the coordinates of A as x, 0, 0. Now similarly, if I take this point, this is purely on y axis, right? So I can take this as 0, y, 0. X and z coordinates will be 0. Okay. 0, y, 0. And similarly, this point D, since it is on x axis, z axis, I can take these coordinates as 0, 0, z. Okay. But I actually want this point P, which is in space, Okay. I want to write its coordinates. So let us see how to write the coordinates. First of all, tell me if OD is Z, then this CE will be Z. Why? Because I told you this is a cuboid, and in cuboid each face is a rectangle. So in rectangle opposite sides are equal. So if OD is Z, CE will be Z, and if CE is Z, so will be PB. This will also be Z. Again rectangle. Which rectangle? CBPE. This rectangle. Now, can anyone tell me, diagram is right in front of you. Can anyone tell me what will be the coordinates of B point? B. Can anyone tell me where B point is situated and what will be its coordinates?
So x comma y comma 0.
0.
Please repeat once more.
A comma C comma 0.
A comma, you should say in terms of x and y z, no? So please repeat.
So X is A, Y is C, and Z is 0.
Z is 0. Okay. All right. So try to understand. See this OC length is Y, right? If OC length is Y, then AB length will be Y. Same concept, rectangle. Now you are at point A and you want to go to point B, which is just in a direction perpendicular to it, in a straight direction, right? So what should be the coordinates of B? X comma Y comma 0. Y. See this labeling, these coordinates, they are very important. Okay, you will be required to use these things. Point B is in XY plane. Just like imagine the point B is on the wall and the wall's name is XY plane. So what will be absent there? Z coordinate, right? So the coordinates of the point are X comma Y comma 0. Now from this point B, you are moving towards point P. Again in a direction perpendicular to it. How much distance? Z. So this point P, what will be the coordinates? X comma Y comma Z, right? This point P is not on ZX axis. It is not on X in XY plane. It is not in YZ plane. It is not in ZX plane. Where it is? It is in space. Okay. So what are the coordinates? X comma Y comma Z. Now try to understand. When you are having some point here, no, some point P, you used to write the coordinates as X comma Y. How? You used to go in the direction along x-axis at a distance x and then in a direction perpendicular to it y, and you used to get the coordinates at x comma y. Now what about point P? Try to understand the path. First you will move from O to A. You will cover x. Then you will go from A to B. You move a distance y. Coordinates become x, y, 0. Then you move a distance z. Okay, perpendicular to this wall in space. By what distance z? What are the coordinates? X, y, z. Okay. So the path is something like this. Path is something like this. See, you go this side, then this, and then imagine that here you are keeping your pen in a direction perpendicular to this point. Okay. So that is the direction X, Y, and if I try to write this Z. Now this is not in the plane. Okay. This red line is actually perpendicular to this green dot. Consider like this. So X, Y, Z. I hope you get it. So what do you observe? That if the point is in 2 dimensions, the coordinates are x comma y. If they are in 3 dimensions, the coordinates are x, y, z. Now let us come back to this octant and everything. See, since we are saying that there are 8 octants, okay, there are 8 octants, so let us write the octant number. These are the octant numbers. Okay, now let us write the octant name. Listen very carefully. In the first 4 octants, x and y are positive. Sorry, in the first 4 octants, sorry, I repeat, in the first 4 octants, z is positive. Z is positive, okay. And O means origin. Then what will be changing? X and Y will be changing. Now, in first 4 octants, you use this thing. You use this thing. Just like we used to write in 2 dimension, no? First octant means try to imagine like first quadrant. In first quadrant, X and Y are positive. That is why I have taken O, X, Y, Z. Second quadrant, X is negative, Y is positive. See here, X is negative, Y is positive. Third quadrant, both of them are negative. Both of them are negative. Okay. And fourth quadrant, X is positive, Y is negative. Fine. Now, what about the next 4 octants? In the next 4 octants, Z will be negative. O stands for origin, and then repeat this cycle once again. Fifth quadrant. So there is nothing like fifth quadrant. You are basically, you have completed one round and you are again in the first quadrant. So it will be X, Y. Then sixth quadrant, which means actually second quadrant. Okay. So that will be X dash Y. Then X dash Y dash. And finally you will write X, Y dash. So very easy to remember. Okay. There are 8 octants. In the first 4, Z is positive. In the next 4, Z is negative. O stands for origin. And how to write these X and Y? Just like you used to write in 2 dimensions. Okay. So when I write capitals without dash, that means they are positive directions. And when I use this dash, that means it is representing the negative direction. So now it is very easy to write the sign convention. Okay. This is plus plus plus. That means in first octant all the three coordinates will be positive. Okay, then you can fill it by your own. X is negative, next two positive, then third one these two negative, z positive. Okay, now it is simple, you have to just observe this and write here. Then this is positive, next is negative, then again positive. Okay, now repeat this with the last coordinate as negative, right? So plus plus minus, then minus plus minus, then minus minus minus, and finally last one, this one, this is plus minus and minus. I hope you get it. Okay, first four octants z positive, next four octants z negative. And how to represent a point in a 3D? X comma y comma z, right? So they can ask the question like this: which of the following octants, which of the octants the following points belong? Okay, just a minute. Name the octants in which following points lie. And the answer, parts are there. We will take some parts. 1 minus 2 3, 3 5 minus 7. You can just look at the points. Okay, compare it with 2D, see the value of z, and you will be able to write the octant number. Very easy. Yes, who will tell me the first one?
So four.
First is fourth, that is correct. Because see, x is positive, right? First you consider the first two. Or it is better if you take the z first. So z is positive, z is 3. That means it is going to be in the first four octants. Now x is positive and y is negative. It happens in fourth quadrant. So it will be fourth octant. Okay. Now the second one.
So five.
Fifth one is correct because see, x and y are positive, but actually z is negative. Z negative means from 5 to 8. But since x and y are positive, so it is like first quadrant. That means it will be the fifth one. Okay. Fifth one. Yes, third one.
So seven.
Yeah, that's correct. Seventh quadrant. Okay. Seventh octant. Because see, z is negative. So last four and x and y negative, that means third quadrant, which will be behaving as seventh octant. Are you getting it? See, in the first round, it is like first, second, third, fourth. Second round is fifth, sixth, seventh, eighth. But actually the fifth one that is corresponding to the first. Why? Because there is nothing like fifth, no? Only four parts. And why we are writing fifth, sixth, seventh, eighth then? That is because of the direction of z axis. In first four, the z is pointing towards plus z, and in the next four, it is pointing into the screen. Okay, for first four, we are taking a vector. You can consider vector or a line whose direction is outside the screen. Okay, and in the next four, it is going to be into the screen. That is why we are having these kind of octants, right? Then fourth one, all of them are positive, so it is first octant. Yes, because z is positive and x and y are positive as well. Okay, so I hope this is clear. Now some things we have already discussed, but I will write it here once. Okay, if any point in x-axis can be taken as, on x-axis can be taken as, I'm talking about 3D right now. Okay, can be taken as
So the
x.
positive, so the
Sorry.
positive z direction will come out of the screen.
Yes. It is just a convention. No, it is just a convention. Like, see, when we make a two-dimensional plane, no, we say that this direction is positive, right? The right side of origin is positive. When we talk about x and we write the number 0, 1, 2, what is this? This is just a rule. Okay. It could have been the opposite also. We could have taken numbers like this. Okay, 0, 1, 2. But we are taking one standard convention. Okay. Everywhere this will be followed. It is just that. Okay. Similarly, outside the
Yes.
screen, we take z positive. Into the screen, we take it as negative. Okay. Now, this we have
Yes.
already. Yes. Anything else?
No, sir.
All right. So let us take the next point. So we were discussing any point on x-axis can be taken as x comma 0 comma 0. Why? Because if the point is on x-axis, then there will be no y and no z. Okay. So those coordinates are 0. Similarly, any point on y-axis can be taken as 0, y, 0. And finally, any point on z-axis can be taken as 0, 0, z. This is one thing. It will be of use for you when you will be solving questions. Again, any point in xy plane can be taken as Can anyone tell me? Any point in xy plane will be
XY0.
Yeah, correct. Because see, if the point is in xy plane, that means it will have x and y coordinates. So what is missing? Z. Z will be 0. Similarly, any point in yz plane can be taken as 0, y, z. Okay. Symmetry is also there. You can easily remember these things, right? Any point in zx plane can be taken as x, 0, z. Okay. This thing. Now another important thing. Okay, important results. For this, I will make that diagram once again. This is x, this is y, this is z, this is origin. Then we marked all the points. If you remember, see, this is x, 0, 0. This is 0, y, 0. This is 0, 0, z. Then this point comes out to be x, y, 0. We just discussed how. This point, since it is in yz plane, so it will be 0, yz. This point is in zx plane. This is on the floor, right? Floor is zx. So x, 0, z. And this point is in space. This point is in space and its coordinates are x, y, z. Okay. X, y, z. Now what are the points which we are going to discuss here? Okay. The first is distance of point x, y, z. Okay. These results will be used in solving the questions. Distance of point x, y, z from A xy plane is, B yz plane is, and C zx plane is. Can anyone tell me what is the distance of this red point? Okay, from xy plane.
Z.
Sorry, please repeat. How much?
Z.
Z, yeah, that is correct. So I will just do the slight changes there and I will say it is mod Z. And the reason is obvious. See, this distance, here it is okay. Here you can write Z because it looks like we are talking about positive directions. But the point will not always be in positive direction. No, it can be anywhere else. So actually, when we talk about this distance, okay, the coordinates are 0, 0, z, but it is better to take distance as mod z. Why? Distance cannot be negative. Similarly, this is like, see, here, when we talk about first quadrant, you will understand what I'm trying to say. If I take point as 1, 2, I say this distance is 1 and this distance is 2. Okay, fine. But if I take point here, will you say that this distance is -1 and this distance is 2? It will be wrong, no? You cannot say -1. So what about distance? Distances are positive, right? Coordinates can be any. Distances are positive. Now why we are using Z or mod Z? This is the next question. For that we can use the geometry here. See, this distance is Z, okay? Then being a rectangle, this will be Z, and being a rectangle, this will also be Z, okay? This will also be Z. And this is what? This is the distance of this red point from this point, and this point is on. This point is in XY plane. Okay. This point is in XY plane. So this red line segment is the distance of this point from XY plane. So he said Z. I am modifying it. I am saying mod Z. Reason just we discussed. Okay. And there is a kind of symmetry in the results as well. Because now if you look for the B option, distance of this point from YZ plane. Okay. YZ plane. Where is YZ plane? This is YZ plane. This one. Okay. This one. So you want to see the distance, it will be the length of this line segment. Okay. And this line segment is actually X. Why? See, OX, this is X. Then by rectangle, this will be X. Then by rectangle, this will be X. Okay. So what is the distance of this point from YZ plane? X. What should we write? Mod X. Why? Distance is always positive. Similarly, for last one, it is mod Y units. Okay. How you observe this thing? In XY plane, Z is coming. From YZ plane, X is coming. From ZX, Y is coming. Okay. So easy to remember the result also. Now the second point. Distance of this point from axis. Distance of point XYZ from A, X axis is, B, Y axis is, and C, Z axis is. Even if you can remember one result, no, by symmetry you can write the others as well. Yes, who will tell me what is the distance of this point XYZ from X axis? How you will see that distance? See, same diagram I will be drawing again. Okay. This time I won't be explaining anything, just writing the coordinates directly. Okay. This point is PXYZ. PXYZ. I want its coordinates. Sorry, its distance from the respective axis. So this is X. This is along Y. This is along Z. Okay. Suppose this point is S. Okay. Can anyone tell me the name of the point? This point is S. Okay. Wait a minute. Yeah. Now the point P is XYZ. Who will tell me? Can you just name the distance of this point from X axis? It is which line segment? Distance of P from X axis. Can anyone tell me with the help of diagram that it is which distance? It is not PR. Why it is not PR? PR is the distance of point P from XY plane. Here we are talking about distance of P from X axis. Which is that distance?
So PQ.
Yeah, correct. That is PQ. This is PQ. This is the distance of the point from X axis. Now you want to find this distance. So it is actually the length of diagonal of this rectangle PSQR. Okay, PSQR. And if you remember, see, this is Z, right? This is Z. So this will be Z. And this is Y. So this will be Y. So length and breadth are like Y and Z. And you have to find the length of diagonal of rectangle. So I hope you remember, if L is the length and B is the breadth, the rectangle is under root L square plus B square. So that is why. What is the first answer? It is under root Y square plus Z square. Now I told you there is symmetry. So from Y axis it will be under root X square plus Z square. And here it will be under root X square plus Y square. No need to write anything like mod or whatever because it is already square. Okay, so it will be positive. So these two are important results. Okay, remember this. Okay, then after this, there comes the same type of concepts. Okay, first is distance formula. So if points, please mute yourself. If points P x1, y1, z1 and Q x2, y2, z2, okay, are given, then distance PQ between them. Then distance PQ between them is given by PQ equals, see the formula is same, it is similar to the formula that you have studied in class 10th. Okay, just Z will be coming. So it will be under root of x2 minus x1 whole square plus y2 minus y1 whole square and plus z2 minus z1 whole square. Okay. So what is the addition? Addition is this term, but the appearance of the formula is same. Okay. Just one more term will be there, that is z2 minus z1 whole square. We can even prove it, but we will do it later. Okay. Right now we just need to go through these concepts and solve some questions because chapter is very easy. Only one class will be required. Next we use section formula. Okay. Section formula, this thing is also same. Suppose you have points P and Q and then you have this line segment PQ joining these 2 points. There is another point R, okay, whose coordinates are, let's say, x, y, z, which divides this line segment in the ratio P is to Q. Sorry, M is to N. That means PR upon RQ is M upon N. So I hope you remember the section formula. So how we used to write the coordinates? Who will tell me how to write the value of x? Yes.
Sin x2 plus n x1 upon mn.
Yes, upon M plus
M
N.
plus n.
Upon M plus N, right? This used to be the formula, it is same. It's just that you will have to write it 3 times. Once for x, then for y, and finally for z. So what is z? Z is mz2 plus nz1 upon M plus N. Okay, simple. Now, if a special case was there, if R is midpoint of PQ, okay, then what we used to write? Then the ratio used to be 1:1. That means in place of M and N, we used to put 1 and 1, and the formula used to be x equals x1 plus x2 by 2, y equals y1 plus y2 by 2, and z equals z1 plus z2 by 2. You will find similar kind of questions. Okay, it's just that only one coordinate will be increased, that is the z coordinate. So this used to be, we used to call this as internal division. Remember, the point R is present internally on the line segment PQ, and it is dividing this line segment internally in the ratio m is to n. Then there was this external division. Okay, external division where R divides PQ externally in the ratio m is to n. R divides PQ externally in ratio m is to n. So anyone remembers what was the change in the formula or the result? I mean, these are the points. P is x1, y1, z1, Q is x2, y2, z2, and R is x, y, z. But now it is dividing PQ externally in the ratio. It is like this, externally. That means R is not the part of PQ. It is present on the extended line segment PQ. This is called externally. So here the point is x1, y1, z1. Again, this is x2, y2, z2. R is also same x, y, z, just like the previous case. Just the ratio is now external. Okay, so if you remember, same formula used we studied. Just what were the changes? Change of the sign between these terms. In place of plus, there used to be minus everywhere. These were the changes, nothing else. Okay, we can prove these results using similar triangles. Okay, but not now, not required at all. For internal division, it is plus everywhere. Okay, for external division, we write minus signs here. Okay, just remember this. And for midpoint formula, the ratio is 1:1. Only that's it. Then there are applications of distance formula and everything, which is same as the concepts covered in class 10th. Okay, so by the help of examples, you will be able to revise all those topics. Yes.
Done, sir.
Okay. Now let us start solving the questions. Okay, so this is the first question. Find the distance between the points. Find the distance between the points -2, 4, 1, and so this point P and Q point is 1, 2, and -5. Solve these questions very quickly. Okay, do not take much time. Just hurry up. Tell me what is the answer of first question.
It's 7.
Yes, 7 is correct. Okay, just use the distance formula. Okay. See how you will use the distance formula. PQ equals under root. See, the formula is x2 minus x1 whole square. So 1 minus of -2 will become 3. then 2 minus 4, that is minus 2 whole square, and minus 5 minus 1, that means minus 6 whole square. Okay, so this is 9 plus 4 plus 36, which is root 49, that is 7 units. Okay, 7 units. Solve the next question. Yes, anyone? A direct question. Why you are taking so much time? You have to find a point on y-axis, no? So let point be 0 y 0, because point is on y-axis. Okay, 0 y 0, correct? Now use distance formula. What else? Under root of 1 minus 0 whole square, because distance of this point on y-axis from the point 1 2 3 is root 10. Okay, so 2 minus y whole square plus 3 minus 0 whole square is how much? Root 10. Square both sides and simplify this. So this is 1 square, this is 2 minus y whole square, this is 3 square, and what is there? This is how much? 10. Okay, so this will be cancelled. Actually 1 plus 9 is 10, so 2 minus y whole square is 0. Okay, that means 2 minus y is 0. What is the purpose of writing plus minus? Y is 2. So what is the point? Required point is 0 to 0. Simple. Third question, if the distances of a point in space from x, y, z axis are 3, 4, 5 units respectively, then find its distance from origin. Then find its distance from origin. Solve this from origin.
So root
How much? Root?
50.
Root 50. Yeah, I think that's correct. Because see, what you will do, you will assume some point. This is a good question, okay? Remember for your school exams. So let point be x, y, z. Because you are not given the coordinates, no? So you will assume the point as x, y, z. Now use the formula. What I told you, distance from x-axis is under root y square plus z square. This is the distance of the point from x-axis and it is given equal to 3. What else is given? Distance from y-axis and distance from z-axis. Okay. What you have to find? You have to find is distance from origin. What are the coordinates of origin? 0, 0, 0, right? So if we assume this as O, then what is OP? Use distance formula, it is under root x square plus y square plus z square. You need this value, right? You need to find this value. What you are going to do? You are going to square these equations, right? Y square plus z square will become 9. X square plus z square will become 16. X square plus y square will become 25 and you will add all these equations. You will add these three squared equations. On the right hand side you will get 50. 9 plus 16 plus 25. In the left hand side you will get x square 2 times, y square 2 times and z square 2 times. Okay. Okay, so it will not be root 50, actually it will be 5. Okay. You divide both sides by 2 also. You divide both sides by 2. You will get this value as 25. When you put this value here, no? When you put this value here, what will be the answer? Root 25. That will be 5. So 5 units is the answer. Okay. You forgot to divide it by 2. Okay, so I hope this is clear to you.
Yes, sir.
All right. Next question. Prove by using distance formula that the points P1, 2, 3. See what will be your homework for these chapters, you know. Homework will be complete NCERT exercises, okay? And I will discuss them. Only that said, nothing else. So you can try NCERT today and tomorrow, okay? Today and tomorrow you can try, and I'll be discussing day after tomorrow your doubts from 3D. It will not take much time. Okay, please complete it before your exams. Next is R. This is 3, 5, 7. R collinear. So by distance formula, you have to prove that 3 points are collinear. Can anyone tell me how you are going to do this? How you will use distance formula to show 3 points are collinear? Anyone? You might have solved this type of question in class 10. Just Z coordinate is there, no? What else? Rest everything is same. So how we can prove that the 3 points are collinear using distance formula?
So addition of two sides will be equal to the biggest length.
Yeah, correct. So first of all, you find these distances, no? PQ, QR, and PR. You find the distance between 2 points taken in pairs. So first we find PQ. So I will be writing the values. Okay, so this will be 2 square with 3 square. This will be 4 square, and the value will be 25 root 29 units. Okay. Then QR will be 4 square, 6 square, 8 square. This is how much? 116 units. You can further factorize this. You can write it as 29 into 4, and 29 into 4 means 2 root 29 units. Okay, simplify this, only then you will come to know whether they're collinear or not. If you will write root 116, you will not be able to get the answer. Then PR, distance between P and R. It is 2 square, 3 square, and 4 square. This is same as the first one, root 29. Now it is very easy to see that the sum of PQ and PR is equal to QR. Okay. The sum of first and third is equal to the value of the second one. This is the condition of perpendicularity of 3 points. How the points are situated? The situation may be something like this. Q point will be here. Okay, P point will be here, R point will be here. When you add QP and PR, you get QR. Got it? So this is the condition. Whenever the sum of distances between two pairs is equal to the distance between the third pair, we say that the points are collinear. This implies PQ are collinear. Okay. I hope this is clear. Then see, there is one formula. Actually, this also you learned in 10th only. Okay. There are 3 points x1, y1, z1, x2, y2, z2, and x3, y3, z3. Okay. They are vertices of a triangle, and these are medians. Okay. The point of intersection of medians is called centroid. I hope you know this. Okay. What are the medians? A line segment which is drawn from a vertex to the opposite side such that it bisects the opposite side. So 3 line segments are there, 3 medians are there, and where they meet is called centroid. So coordinates of centroid K. Anyone remembers the formula? Coordinates of centroid K.
x1 plus x2 plus x3 by 3, comma
Yes,
y1.
yeah, that's
So
correct. Just add z also. Okay, now add z also. So 3 coordinates will be there, right? This is x coordinate. This is your y coordinate. and this is your z coordinate. Okay, z1 plus z2 plus z3 upon 3. Okay, simple. So just remember class 10 concepts with respect to section formula, distance formula, and centroid, and add one more coordinate, z coordinate, and you will be able to write the coordinates of centroid, distance formula, and everything in 3D. Simple. Just the introductory part was different, like octant and distance from x, y axis and this and that. Rest is everything same now. Okay, let us solve this question. If the origin is centroid of triangle PQR, is centroid of triangle PQR with vertices P as 2a26, Q as -4, 3b minus 10, and R as 8, 14, and 2c. Then find value of ABC. Then find value of A, B, and C. Okay, find it. Question is simple. No? You just draw any triangle. Okay, mark the point. Say P point is 2a26, Q point is -4, 3b minus 10, R point is 8, 14, and 2c, and just take this point as origin. Origin means 0, 0, 0. Apply the formula. Simple. Okay, apply the formula. X coordinate is 0 and you write it as x1 plus x2 plus x3 by 3. See, from here you will get a simple. Then y coordinate 2 plus 3b plus 14 upon 3. You will get the next value b. And by z coordinate z1 plus z2 plus z3 by 3, you will get the value of c. Okay, so 2a plus 4 is 0, a comes out to be -2. Simple questions. Okay, 3b plus 16 is 0, b is -16 by 3.
Can you please scroll up a bit? So I missed this question.
Wait a minute, let me complete this. And 2c minus 4 is 0, so c comes out to be 2. Okay, so a, b, and c. These are the values. Okay, now you can see what you want. Anyone having any doubt? Is it clear?
No, sir.
All right. Yeah, now what about your assignment? This is the last day for the discussion. If you have doubts, you can ask me. PNC level
So when
1.
did you?
Sorry,
So when did you give the assignment?
that question bank now. Question bank level 1.
Okay, sir. So the one which Fina ma'am uploaded or you uploaded?
I think Phenom only uploads every time now.
Okay, sir.
It was shared well. I mean, so many days ago. No? This PNC question bank level 1. You guys are asking doubts as well.
Okay. No, sir. I thought you had given about complex numbers.
This only. Assignment means this question bank only. Okay.
Okay, sir.
Yes. So anyone having any doubt, speak up. Ask your question on this.
So question 44, 45.
44, 45.
So 56, the question.
Which one? 50?
56.
56. Okay. 56. Okay, so what is 44? Okay. See, question number 44, we use this concept. Suppose that we have parallel lines like this. Parallel lines. Just 2 or 3 or like and it can be any number. And they are intersected by another set of parallel lines like this. So they are asking how many parallelograms will be formed. Okay, like this. Now try to understand this thing. Suppose we have two parallel lines like this and two parallel lines like this. So the question is how many parallelograms are there? Answer is 1. So what we do, from these red lines we will have to select 2, and from the black lines also we will have to select 2, and when we multiply them we get the number of parallelograms formed. Suppose we have 3 parallel lines and another set of 3 parallel lines. Okay, now the question is how many parallelograms are there? See, try to do the counting first. You want to count the number of parallelograms here? 4 are the smaller ones. The ones that you can see just by looking at the diagram, 4. But there are more parallelograms. See, this is the 5th one. This is the 5th parallelogram. Okay. Then this is the 6th parallelogram. Then this is the 7th parallelogram. This is the 8th parallelogram. And finally, this one. This is your 9th parallelogram. So how we do it? How many red lines are there? 3. We select 2. And how many black lines were there? 3. We select 2 and multiply them. Okay. How many parallelograms you will get? 9. Similarly, now let us use the same concept here. How many black parallel lines are there? M. How many red parallel lines there? N. You select 2. You multiply them. Upon m minus 2 factorial into 2 factorial. This is n factorial upon n minus 2 factorial 2 factorial. Okay. When you simplify this, okay, when you simplify this, so this you can write as m into m minus 1, then m into m minus 1, and that will be cancelled. M minus 2 factorial will be cancelled. It will be 2 here. Then similarly n into n minus 1, n minus 2 will be, n minus 2 factorial will be cancelled from denominator. It is 2 here. So ultimately it is 4. So D will be the option. Okay, D will be the option. So you can remember it like as a standard result also, like m parallel lines intersected by another n parallel lines. Number of parallelograms are MC2 into NC2. Simple. Then question number 45. This is about number of squares. See, for number of squares in a chessboard, we will have to recognize a pattern first. Okay. So in a chessboard, there are 9 vertical lines and 9 horizontal lines. Okay, so what happens in a chessboard? They are asking the number of squares. So what you will do? You will find the number of squares by the help of the size of the square. So number of squares, size. Now try to understand. Generally people say 64 squares are there. No, that is incorrect. 64 squares means the ones that you are observing according to the size 1 into 1 or 1 by 1 or the smaller ones. Okay, but these are also the squares. This one, see this. This is also a square. Have you taken it before? No. What is the size of this? It is 2 by 2. So try to understand one thing. Of the size 1 by 1, there are 64 squares. That means 8 squares. Now we will increase the size 2 by 2. 2 by 2 you will get 49. Why 49? Try to understand. This green one is the first one. Then this green one is the second one. Then this green one is the third one. Then this is the fourth one. Then this is the fifth one. Then this is the sixth one. And similarly, this is the seventh one. 7 you will get like this. 7 you will get like this. So just like you are getting 64, now you will get 49. Now there will be another square which will be of the size 3 into 3. Okay, 3 by 3. Like this is 1 square. Okay, this is 1 square. What is the size? 3 by 3. So you will get 6 like this and 6 along this. So how many squares you will be getting? You will be getting 36 squares, which means 6 squares. You can see the pattern also, right? Some pattern is going on. What will happen? You will go on doing it and finally you will get the biggest square, which is the chessboard itself. Okay, the whole chessboard is a square. Its size is 8 by 8. Number of squares 1. How to find 1 squares? Now we need to count how many squares are these. Okay, we need to count how many squares are these or these values. What is the sum of all this? So for this, either you can add them one by one or you can use the result for sum of squares of n natural number. And if you remember, the formula was n into n plus 1 into 2n plus 1 by 6. And when you will solve it, you will get 204 as the answer. Okay, sigma r square. Remember, r1 to n. What was the formula? n plus 1, 2n plus 1 upon 6. So here in place of n, you are going to put 8 because this is from 1 square to 8 square. Okay. So this particular question also can be remembered because see, number of squares are not going to change in future. Chessboard is fixed. So number of squares, you can remember it by memory. 204. 64 is the wrong answer. Now question number 56. Question number 56, we have to do the factorization first because they are asking something about the factors. Okay. Now you may be confused with this proper factor thing, no? Because I have taught you only the number of factors, but what is this proper factor? For that, you do the prime factorization first. Okay, 3780. Just a minute. Okay, we do the factorization. So 3780 divided by 2, it is 1890. Then we again divided by 2, it is 945. Now we will divide it by 3. It is 315. Again we will divide it by 3. It is 105. We again divided by 3. It is 35. And then 5 and 7. Okay, 5 and 7. So what is the prime factorization? 2 square 3 cube 5 to the power 1 7 to the power 1. If you remember number of divisors or number of factors, the formula was power plus 1 into like that, you know, alpha 1 plus 1 into alpha 2 plus 1 into alpha 3 plus 1 into alpha 4 plus 1. Okay, so this used to be how much? 3 into 4 into 2 into 2. This is 48. Okay, number of divisors 48. Now number of proper divisors, you can learn about this now. Number of proper divisors are number of divisors minus two numbers. Which are those two numbers? 1 and the number itself. Number of divisors and 1 and the number itself. That means if someone asks you, like for example 24, you write the divisors. So 1, 2, 3, 4, 6, 8, 12, 24, right? These are the divisors of 24. How many? 8. If someone asks what are the proper divisors, you strike first and last. That means 1 and the number itself. How many will be remaining? 6. Similarly, here we have 48 divisors for this number. They are asking about the proper divisors. So you will strike 2 out of these. One is 3780 and remaining is 1. Okay. So how many proper divisors will be there now? 46. Okay. This is the definition of proper divisors. So I hope this is clear to you. Now see, I don't know what you guys are doing. You just hardly ask any doubts, which is very surprising. See, these 2 days, that is, I mean, till tomorrow, I'm giving you one more day. Okay, if you haven't done these questions, please do them. Okay, I'm giving you one more day. If you have any doubts, you can ask tomorrow as well. All right, because from Thursday, I will discuss this 3D doubts from NCERT. Okay. So that's it for today from my side. See you tomorrow.
Thank you, sir.
Bye everyone.
Thank you, sir.